Hello everyone. So this is the next video on linear algebra. We will solve few problems in this class. So first problem is regarding the linear dependence and independence. However, if the given vectors is, let me say it is 3 cross 3 matrix. If you have any square matrix, the best idea is to check through the determinants. So if the determinant is non-zero, it is linearly independent. If it is equals to 0, it is linearly dependent. Or else if you see one is the scalar multiple of the other, so this is one way. Second way is, if you say, think about some vector is there v1, v2, v3. If v1 is the scalar multiple of v3, or else v1 is the scalar multiple of v2, or else any one of these is the scalar multiple of the other, then we say that it is linearly dependent, that we had observed in the result. Before you solve all these problems, kindly look to the result, then come to make an attempt to solve this problem. Again, if your dimension is V is a vector space over F of dimension n, if you have n plus 1 vectors, then it is linearly dependent, or else more than n plus 1, it is linearly dependent. Keep those things in your mind. So the first one, minus 1, 2, 1, 3, 0, minus 1, minus 5, 4, 3. So I will just give you the hint for this since it is easy. Minus 5, 4, 3. So there is another one method to find the determinant. If you have 0 entry, go with the usual determinant expansion. If not, see, you just repeat the first two columns. So repeated first two columns, then multiply likewise, right? 1, 0, 3 is there, so it is, first thing is 0. Again this 2 minus 1 minus 5, so plus 5 into 10. You need to add them. Again 1, 3 into 4, it is 12. Minus, in between you need to put the minus sign. Again come reverse. 3 3s are 9, 9 2s are 18. Again it is plus 1 plus 4. Again it is 0. So it is 12 minus 22, it is minus 10, non-zero, so it is linearly independent. Or else if you are comfortable with usual expansion, you can go with that. This is, you can, however, if it is given 3 cross 3, then only you are entertained to check with these things. Or else you need to use the usual definition way, whether all the scalars are 0. If all the scalars are 0, it is linearly independent. If some scalar is non-zero, it is linearly dependent. You need to go in that way. So it is linearly independent. This one, look to this, only two vectors are given, 2, 4 is there, 3, 9, 5, 25. This is not the scalar multiple of this. So it is linearly independent. Again check for this using the same way. You will get linearly dependent. You will get the determinant 0. For this also you will get the determinant 0. So it is linearly dependent. Kindly try these two. Next question is, let V be a vector space over the field F where V is Cn, that is n tuples taken from the complex. We need to verify whether the following are subspaces. If they are subspaces, definitely everything is given as finite dimensional. So we need to think about what will be the dimension. The first thing is W1 is A1, A2, etc. An. Summation A is 0. So let me think about some, take W1 to be, take n is equals to 4. It will form the subspace that you can check. Alpha into U plus beta into V will belongs to W1 whenever U and V are in W1. Kindly check this. This will form the subspace. But what will be the dimension? Dimension is, see, summation must be 0, means A1 plus A2 plus A3 plus A4 is 0. So what is A1? A1 is minus of A2 plus A3 plus A4. That means one fellow A1 can be written in terms of A2, A3, A4. If you know these three things, you can find A1. That means this is not needed. So dimension is 3. If you have 4, dimension is 3 means it is reducing to 1. So it is n minus 1. Idea is clear? Second one will also form the subspace. A is 0 for I dividing n. If I divides n, then it will form the subspace. Sorry, A will be 0. When it will be 0? When I divides n. So here, this will form the subspace, but what is the dimension? See, sir, how it will form the subspace? To know whether it's a subspace or this thing, you just start with those things, finally you end up with the answer, whether it will form or it will not form. Idea is clear? Again, what is the dimension? Dimension is n will be there, exactly, but you need to subtract some people here. Here n was there, I subtracted one fellow, I came to know here, but how many fellows here I need to subtract? That is, how many divisors are there? That much. N minus d of n. What is d of n? Number of divisors for n. Idea is clear? Again, this one, third one will form the subspace. A1 is mu into an. This will form the subspace. Take this to be u and v to be some b1, b2, etc. up to bn. Just say alpha into u and beta into v. Still it will form the multiple of mu. This a1 b1 will be the multiple of mu, so it will form the subspace. See, likewise you need to encounter these things. Every time you cannot solve all these things. You will get hardly 45 to 50 seconds to solve one problem of 3 marks. So this will form the subspace. And what is the dimension? A1 is mu into a1. For a1 can be scaled by this. That means one fellow you can omit, right? So it is n minus 1. Idea is clear? But this won't form the subspace. Why it won't form the subspace? ai by a1 is there, or else a1 by an. But if you think about 0 element, whether 0 element is there here? 0 means 0, 0, 0, 0, 0. An must be 0. But in the denominator you cannot take 0. Such a way that you will get a scalar. That is not possible. So 0 element is not there. So it won't form the subspace. So if it doesn't form the subspace, there is no question of finding in the dimension. So you leave it. How about this? W5 is there. You take n is equals to 4. As I said, a2, a3, a4. a1 plus a2 is 0. a2 plus a3 is 0. a3 plus a4 is 0. a4 plus a5 is 0. Getting? a1 plus a2, a2 plus a3, a3 plus a4, a4 plus a5. Here, what is a1? a1 is minus a2. What is a2? a2 is minus a3. What is a3? a3 is minus a4. What is a4? a4 is minus a5. That means if you know a1, you can find a2. If you know a2, you can find minus of that is a3. If you know a3, you can find a4. If you know a4, you can find a5. That means which is needed? Only one fellow is needed. So the dimension is 1. Think about this. a1, a2, a equals to 0 for I, and it is nothing but Euler-Torsion function. That is phi of n. So it is n minus phi of n is the dimension. But you need to know what is this phi of n, what is this d of n. If n is p1 alpha 1, p2 alpha 2, pn alpha n, if this is the prime factorization, then phi of n will be p to the power n alpha 1 minus p to the power alpha 1 minus 1 into p2 alpha 2 minus p2 alpha 2 minus 1, etc. pn alpha n minus 1. So what is d of n? D of n is alpha 1 plus 1, alpha 2 plus 1, alpha n plus 1. So you should work on these things. You should know these basic things at least. Okay. Next question is, this is a remark. If somebody asks the dimension over Rn over R, it is n. Cn over C, it is n. But what is Cn over R? Cn over R is 2 times n. It doubles. Getting? Because this is isomorphic to this, because any two vector spaces of same dimension are isomorphic to each other. But this is, see, or else take n is equals to 1. What is the dimension of R over R? 1. What is the dimension of C over C? 1. What is the dimension of C over R? Dimension is 2. So that you can generalize this to this. So that means whenever they ask the vector space C over the field R, the dimension must be doubled. What all the problems that I solved, I just used these things. R over R. Okay. The dimension of n cross n symmetric matrix with the first entry is 0 and the trace is 0. So what is the dimension of symmetric matrices? Symmetric matrices means A11, A12, A1n. A21 will be A12 itself. These will be same. Right? A22, A2n. And this will be A13 itself. Right? Likewise, A11 will be here. Getting here A13 will be this. Likewise, ANN. That means if you know this fellow, you can find this fellow. If you know this fellow, you can find the lower half. That means just concentrate on these things. That is enough to generate all the matrix. So A11 is there, A22 is there. This and all, how many elements are there? 1, 2, likewise n elements is there here in the first diagonal. Again, if you can come to the sub diagonal, n minus 1 fellows will be there. Next one, if you come to that, there will be n minus 2. Right? Similarly, if you just come back to this, one element will be there. Add them, 1 plus 2 plus 3 etc. n minus 2 plus n minus 1 plus n. It is nothing but etc. up to n. It is n into n plus 1 by 2. So that is this dimension of symmetric matrices. But he has given some condition. A11 is 0. One condition is given, minus 1. And the trace is 0. Trace is 0 means A11, A22 plus etc. ANN is 0. So minus 1. So it is n into n plus 1 by 2 minus 2. Idea is clear? Then again, fourth one is simple, try to understand this. It is an n cross n matrices where Aij equals to, entries will be equal whenever the I plus j equals to r plus s, whenever the lower index sum is same. So instead of going for generalization, I will just think about applying 3, that is 3 cross 3 matrix. If I take 3 cross 3 matrix, option A will be 9. This will be 9 minus 3 plus 1. It is 6 plus 1. It is 6 minus 1. So it is 7. It is 7 and it is. See, two options are same. That means don't take n is equals to 3. Take n is equals to 4. So it will be 16. Here I will have 16 minus 4 is 12. 12 plus 1 is 13. Again I have 4 into 2, 8. 8 plus 1 is 9. Here I have 8. Options are different. You can take this. Now what is the idea here? Idea here is, I took 4 cross 4, right? A11, A22, A33, A44. This will be as it is. But whereas A12, A13, A14. A12 will be same as A21. These two elements are same. Why these two elements are same? Because it says whenever 1 plus 2 is 3, 2 plus 1 is 3. Again, I have A31 here. This element and this element and this element. All the index sum 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4. So these elements is occupied by one element. This element is occupied by one element. This element is occupied by one element. Likewise, I can find A23, A24, A32, A34, A41, A42, A43, 44. So again, I will have here 1. So 1, 2, 3, 4, 5, 6, 7. Wait a moment. A moment. I'm just checking it. I don't know whether I written the options correctly. What I am doing is right, but still sometimes while I am writing somewhere I went wrong. 2, 3 elements, 4 elements, 5, 6, 7. Oh, here I have, yes. See, this option is 2 into 4 is 8, 8 minus 1 is 7. So option D is correct. Idea is clear. Okay. So now fifth problem, let S is equals to this set. The value of k for which the vectors 3k plus 2, 3, 10 belongs to the linear span. See, whenever v1, v2, vn belongs to linear span, then their determinant is 0. To take v1, v2, vn, the determinant is 0. So how to find the value of k? Just take minus 1, 0, 1, 2, 1, 4 and 3k plus 2, 3, 10. You say determinant is 0. If you do it likewise, you will get k equals to 2. Alright? You see problem it is. Again, this is interesting. The sum of all the elements of a to the power 100, where a is given by this. See, you cannot find a to the power 100. However, try to understand the result. If likewise the question is given, the sum of all the elements of a to the power 100. Find the row sum or else find the column sum. First I will find the row sum. What is this row sum? It is 1. This row sum is 1. This row sum is 1 by 5, 3 by 5, 4 by 5 plus 1 by 5, 5 by 5, it is 1. If they are equal, if the row sums must be equal, 1, 1, 1. So what will be a to the power 100 will be, first row, what is the summation of Ri? I varies from 1 to 3, whole to the power 100. That is first sum, first row sum, whole to the power 100, second row sum, whole to the power 100, plus third row sum, whole to the power 100. So first row sum is 1 to the power 100, second row sum is 1 to the power 100, 1 to the power 100. So it is 3. How about this? See this, if you check row wise, 2 minus 2 is 0, 30 minus 14 you will get around minus 16 you will get. But here you won't get negative value itself. So don't go for row sum. So go for column sum. Minus 1, 1 will get cancelled, 2 and minus 2 will get cancelled. 6 is there, 2, 2, 2, it will sum up to 6, so this will be 0. 15, 15 is 30, minus 30 is 0. Again this will, don't check for the other one, it will be 0. Again what is a to the power 900. So it is column sum now. So 4 columns are there. First column sum is 0 to the power 900. Then again plus 0 to the power 900 plus 0 to the power 900, 0 to the power 900. So it is 0. Next one is, if A is a matrix of order 5, it is an 5 cross 5 matrix whose each column sums to 1. So each C1 is 1, C2 is 1, likewise Ci is 1. Sum of the elements of A to the power 2022. It is 1 to the power 2022, 1 to the power 2022, plus 1 to the power 2022, plus 1 to the power 2022. So 5 times. 1, 1, 1, 1, 1. So it is 5. Idea is clear? So we will solve few problems and we try to end up the first chapter. Thank you.